Hi everyone, I'm Rex and welcome to this course, Arduino for Beginners. Here we're going to be learning how to build Arduino circuits using Tinkercad and kind of the block-based coding and the real thing Arduino with C++. Before I begin the course on Arduino, we're going to start lesson one. This is lesson one. We're going to introduce you to basic circuits, just basic electrical terminology. So the first thing we're going to do is review basic electricity concepts, voltage, how much pressure there is or electrical pressure is ready to enter into a circuit, amperes or the flow, how fast is the flow of the electric current, the resistance, anything on the resistance, anything on the circuit that can actually slow the flow down so that our components don't break. And lastly, Ohm's law, which is the relationship between voltage, current, and resistance. So first, let's start with voltage. Think of electricity just like water in your pipes, okay? So voltage is the pressure that pushes the water or the electricity forward. So think of voltage as the push or force of electricity. It is the difference in electrical potential energy, and we measure voltage by volts V, where 1 volt is 1 joule of energy per coulomb. So think of voltage like this. Imagine before you even turn on your faucet, how much pressure is in the tank. So when you open it, and there's not that much pressure on the other side, you just get very little water flowing out. And then when there's no water at all, you get nothing flowing out. But when there's massive pressure, imagine there's a lot of water that wants to escape. When we open that faucet, it'll be a rush, big rush of water. That is voltage. Voltage is how much pressure there is ready to explode onto the other side. So voltage is basically pressure, but we can think of it also like this. So this would be what 1 volt looks like, just 1 unit of energy per coulomb, 1 joule per coulomb. 230 volts, just notice it got bigger. So everything, each coulomb will carry more joules or more energy. That's voltage. Next, what is amperes? Amperes is the rate of flow. It's the flow of electricity. If voltage is the water pressure, current is the flow rate of water itself. And look at this diagram. One thing is that electricity flows from the positive to the negative part. So it always flows from the positive all the way to the negative. So this is a diagram of electricity flowing, and you'll need to understand this when you hook up your circuits. You need to understand that voltage flows from the positive part of the circuit to the negative part. So what is current? Current is the flow rate of the electrical charge. It is the rate at which electrical charge flows past the point in a circuit. We measure current in amperes or sometimes milliamperes. Amperes for big things. Milliamperes is really for the circuits we're going to be using. And think of it this way. A tiny stream, has a very low flow rate. It flows slowly, while a fast river, has a high flow rate, high current. So while volts is pressure, current is how fast it's moving. And we'll go to the last thing. The last thing is resistance. So if you see here, resistance is anything that opposes the flow of electricity. So if we see here, the electricity is trying to flow into the hand, and the hand is blocking that electricity or slowing it down. So here it's really trying to flow fast, and then you put this hand, and it starts to slow down. So resistance is anything that will slow the electricity. So think of a big river and you put a rock. So that rock or a lot of leaves, and that those leaves will slow down the water and make it not so fast. That rock will slow down the water. It's exactly the same with resistance. Resistance is anything we put that will slow the current. Okay, and so opposition to current flow, we measure this in ohms. Why do we do this? Because without resistance, this would flow so fast. This would flow like wow, and it would destroy the bulb. So without resistance, a lot of our electrical components would get destroyed. There'd be too much voltage and there'd be too much current, and that would destroy a lot of our electrical equipment. Okay, now we're going to actually talk about LEDs now because we're going to use this in our first circuit. Okay, so we're going to have this LED here. I'm just gonna talk about a few things. So for an LED, those small LEDs we have, the voltage it can handle is 1.2 to 3.6 volts, and the current it can handle is between 10 to 30 milliamperes. Right? So this is our first electrical component. It's an LED. This is how much voltage it can handle from 1.2 to 3.6. This is how much current it can handle, 10 to 30 milliamperes. And always when we connect the circuit for LEDs, we connect the positive part of the battery to the anode. This is the positive part of the LED. It will have a longer leg, and the electricity flows out on the negative part, the cathode. Okay? So we'll connect the anode to the positive part of the battery, and the electricity will flow out. It will go over here, light up, and then flows out of the cathode. Okay, we're going to be creating this LED demo in Tinkercad in a while, and you're going to see the electricity flow here to the LED and flow back out of the battery. So this is a simple circuit you can build at home with a battery, a resistor, and an LED. Now, the question is how much, so we know the voltage we want, we know the amperes. This is now what we're going to check. This is the question mark. How much resistance do I put? If I know this is a 9-volt battery, I know this can take 1.2 volts to 3.6 volts. What do I put here? Well, there is something called Ohm's law. And Ohm's law is the relationship between voltage, current, and resistance. And this allows us to compute kind of how much resistance we have to put. So this is the basic formula. Volts equals current times resistance. But with basic math, we could look at it different ways, and we want this one. Resistance equals volts divided by current. Okay? So now we're going to do a sample calculation for the battery, right? So now we know that R, resistance, this is what we want to find because we know that over here we're looking at 1.2 to 3.6 volts and we need 10 to 30 milliamperes of current. So we don't know how much resistance we should put in the resistor. So here, volts, it's a 9-volt battery, and we know we want 10 milliamperes. Okay, so 10 milliamperes. Remember the sign milli is equivalent to 10 to the negative 3 and 0.001. So what we do is 10 milliamperes MA times, right? We'll convert it back to amperes. We'll times 0.001. This equals 0.01 amperes. That's why you'll see that here, 0.01 amperes. So 9 volts divided by 0.01 amperes will give us 900 ohms. So now we know what to put in our basic circuit. So this is the end of the first part where we discussed all these things. Ohm's law, voltage, amperes, and resistance. Ohm's law is the relationship, voltage, the kind of electrical pressure, amperes, the flow of the current, and resistance is anything that opposes it. And we used Ohm's law for this example here. The LEDs 1.2 to 3.6. And then we're going to use this knowledge now. We use that knowledge to compute how much ohms to put in the resistor. And now we're going to go build our basic circuit. So that's it kind of for the first video in this lesson. And see you at the next one.